Hello everyone, welcome to Unlock Maths. Today we have to find inverse Laplace transform of this given function by using convolution theorem. So first here we have to write down statement of convolution theorem. This theorem states that if we know inverse Laplace of two functions f of s and g of s, then inverse Laplace of their product can be found by using this integral, right? So here we have to apply convolution theorem for finding L inverse of this function. So here we have to write down f of s as this given function. Here we have write down this capital F of s as this given function. Now we have to find its L inverse. So we get here L inverse, this is a one function of t, right? So for applying this convolution theorem, what we have to do? We have to write down this given function in two functions such that we can find their inverse Laplace easily here. So we have to write down this is as 1 upon s minus a into this 1 upon s plus a its square, right? We will call this is as a f of s into g of s. So where we have write down this f of s as a 1 upon s minus a, and next function this is g of s as a this 1 upon s plus a its square. Now we can find inverse Laplace of these two functions by using standard results. Now L inverse of this f of s is equals to L inverse of this 1 upon s minus a, and we know that L inverse of this given function, this is e raised to a t, right? And we got this is a f of t. Next here we have to find L inverse of this g of s, and this is given by L inverse of 1 upon s plus a its square, right? Now we know that we have to find this inverse by using first shifting property of inverse Laplace transform. Now for applying this property, yes, here we have this a, so we have to take this a outside. So here we have to write down e raised to minus at and L inverse of this 1 upon s square, right? So this is e raised to minus at as it is, and we know that L inverse of 1 upon s square, this is a t, right? So we got this is function g of t, this is L inverse of this g of s. So we have find here f of t and g of t, right? Now we have to apply convolution theorem, and we have this L inverse of f of s into g of s. This is given by this integral within limit 0 to t of f of u into g of t minus u. This integral is with respect to u. Now we want here f of u and g of t minus u. So we got here this is f of t as a this e raised to at. So f of u is obtained by replacing this t by u. So we got here f of u as a e raised to au. We have replaced this t by this variable u, right? And same here we have g of t is e raised to minus at into t. So this is, we want here g of t minus u. So what we have to do, we have to replace this is t by this is t minus u. So we have here g of t minus u, this is e raised to a into t minus u, and this t as a t minus u, right? So we have to put down these two values here. So we have here integral within limit 0 to t f of u, this is e raised to au, and g of t minus u, this is here we have e raised to minus a into t minus u into this t minus u, right? And this integral is with respect to u. Now we have to simplify this integral here. So this is integral within limit 0 to t e raised to au. Now we have to simplify. This is e raised to minus at into e raised to this minus minus get plus. So here we have e raised to au and this is t minus u. This is, so on simplification, yes, here we have e raised to au, 2 times here we have, so this is e raised to, this is twice au, this is e raised to minus at into this t minus u into du, right? Now, since this integral is with respect to u, we have to take this e raised to minus at, this is outside this integral. So next here we have now here we have this exponential and this algebraic function. So we have to apply integration by parts. For this we have to apply this layered rule. So we have to write down this exponential function as a second function. So we have integral of t minus u into e raised to twice au. So we have to apply generalized rule of integration by part here. So here we have this first function into integral of second. This is with respect to u. So here we have e raised to twice au upon this twice a minus derivative of this function with respect to u. So here we have, this is minus 1 into integral of this function. So this is here e raised to twice au upon this twice a and this twice a. This is here we have twice a its square, right? Limit within 0 to t, right? Next part get vanish here since second derivative of this first function is 0, right? So now we have to put down the limit here. So for this we have to do the simplification. So here we have e raised to minus at. This is t minus u into e raised to twice au upon twice a. This minus minus get plus. So here we have e raised to twice au upon 4a square. And now here we have to apply this limit 0 to t. So here we have e raised to minus at. Now first we have to put upper limit t. So t minus t, this is 0. So this part gets 0. Next here e raised to twice a t upon 4a square, right? Now for, yes, here we have put down the limit u is equals to t and now we have to put u is equals to 0, right? So when we put u is equals to 0 for lower limit, so here we have t minus 0, right? And next here e raised to twice a into 0 upon this is twice a plus this is e raised to twice a into 0 upon 4a square. So here we have, this is e raised to minus at. This is for complete here. So here we have e raised to twice at upon 4a square. Now on simplification, this is t into, now e raised to 0, this is 1 upon twice a, right? And same here e raised to 0, this is 1 upon 4a square. Now we have put down the limit. Again we have to do the simplification. So here we have now this minus get inside. So here we have now here we have find L inverse of f of s into g of s. So here we can do the simplification. We can take this is here 1 upon 4a square. This is outside. So here we have again if we want we can do the simplification of this is. So here we have, yes, we can take this e raised to minus at. This is inside this bracket. So remaining here we have 1 upon 4a square. When we take this is inside this bracket, remaining here e raised to this 80, right? And this is twice 80 e raised to minus 80. Yes, and same here e raised to minus 80. So this is the required inverse Laplace of given function, and given function is, this is, yes, 1 upon s minus a into s plus a, its square. So we have find inverse Laplace of this given function by using convolution theorem, right? Yes, we have applied this first integral for finding inverse Laplace. Now we will try to find out inverse Laplace by using this second integral, right? The meaning of these two integral is the same, just only notation of this function have get changed here, right? So let's try by this second integral. Yes, we have find f of t and g of t, right? So f of t is e raised to 80 and g of t, this is e raised to minus 80 into t. Now we have to apply this integral. So we want f of t minus u. So what we have to do, we have to replace this t by t minus u, right? And same here we want g of u. So we have to replace t by u. So here we have e raised to minus au into u. Here we have replaced this is t by u, and here we have replaced this is t by t minus u. Okay, now by this integral we have to find inverse Laplace, right? So here we have find inverse Laplace transform by using the second integral of convolution theorem, right? Now we can check that we got the same answer as we have find earlier here by using first integral, right? So in this way we can find inverse Laplace transform by using convolution theorem. Now for applying convolution theorem, we have to note down that we have to write down this f of s in two functions such that we can find their inverse Laplace easily, right? And we can apply this two integral as per our convenience. So yes, In this way, we have proceed for finding inverse Laplace of this function. So that's it for now. See you in the next video. Thank you. Keep watching.